GraalVM 22 is out, a release which brings higher performance, better native image usability, GitHub Actions for GraalVM and much more. My name is Liana, Lixandru, and in this video we will be looking at how to create a microservice in Micronaut, building it as a native image and then running it in Oracle Cloud. To start off, please make sure you've installed and properly configured Micronaut and GraalVM, and that you have a free account on Oracle Cloud. As an IDE, I will be using Visual Studio Code, and the first step is to look at our Micronaut application. So I've created the app using the GraalVM features, the Maven build environment, and Java as a language. As you can see, I've got here a few files that I've created. One of them is the Pojo that's called quote. Here you can see that I've annotated the class with @introspected to generate bin introspection metadata at compilation time. This information can be used, for example, to render the Pojo as JSON using Jackson and without using reflection. So here we are defining a string called quote that then we will be using in our service, where we are using the Jakarta inject singleton, and then we are using the singleton annotation to designate our class quote service as a singleton. We have defined a list of quotes in our class, and then a method that will return a random quote each time the service is called. And finally, a quick look at our controller. The class is defined with the @controller annotation mapped to the path /quotes, and the @get annotation maps the HTTP GET request on /random to the index method. So this is our simple application. Now, in order to be able to build it as a native image and run it in Oracle Cloud, first of all, we will need to publish it on a Git repository so we can then retrieve the code and build the native application on our virtual machine on compute. So to do that, we will do a git add -a dot and then do a git commit. Let's call it initial commit. And then git push origin. There we go. Now I've got my code set up in a repository that then I can use on my compute machine. So going to Oracle Cloud here, we are going to go to compute instances and create a new instance. Let's call it Micronaut demo, for example. And here we need to choose an image and a shape. We'll be leaving it as the default Linux 7.9 image. And for the shape, I will be giving it one more OCPU. Let's see here. Two CPUs, select shape. There we go. For the networking, here you can create a new virtual cloud network and a new public subnet, but for us we will be using some that we have created previously. And assign it, of course, a public IPv4 address so we can then access our instance. As for connecting to the instance, we will be using SSH, and for that we will need a pair of private and public keys. Oracle Cloud can generate those for us, so I will just download them, leave everything else untouched, and click on Create. And now my instance will start provisioning. Meanwhile, while our instance provisions, we need to change the permissions on our key files. So we will be doing a chmod 400 on downloads and our SSH keys. There we go. Let's clear this. And we're waiting for our instance to be provisioned. Once our private IP address is available, here we go, we can connect to our instance using the key that we have downloaded, the IP address and the username. So I will be copying this public IP address and moving back to my terminal. Here we will do an SSH -I, the key, OPC at my IP. Yes? And now we have connected to our Linux image. Now, what we need to do is install GraalVM native image on this virtual machine. So we will do a sudo yum install GraalVM 22, and we will be using Java 17 native image .x86 64. We'll be waiting for the package to install. And then we also need to add our port 8080, the default port for Micronaut, to the firewall configuration so we can access and call our microservice from our local machine. While this is installing, I will go to GitHub and get the link for my repo. There we go. Just copy this. Go back here and then do a sudo yum install git. Yes. Now we've also got git installed and we can do a git clone on my repository. Very well. Now let's add port 8080 to the firewall. To the public zone. .8080 on TCP. Oh. Let's just use the right command here. And then we need to reload the firewall. Okay, now that that is done, we need to build our application as a native image. In order to do that, I will cd to my folder where the application has been downloaded. And here we will be running Maven package -d packaging equals native image. And now we sit back and relax, grab a cup of coffee, you know, take a break and wait till our build finishes. This will probably take us a few minutes. So basically what this does is it calls from Maven the GraalVM native image package and builds us a native image of our Java application. So we'll be waiting until the steps have finished, and then we can run the application and test it. Micronaut also has the possibility and allows you to create containers for Kubernetes, so you can run their application directly inside Oracle Container Engine for Kubernetes. And also they've got the option of allowing you to create functions in Oracle Functions. So if you want to run your Micronaut microservices as serverless functions, you can also do that. Just like we created this application using the features argument equals GraalVM, we can use similarly the argument Oracle minus function to add Oracle Functions support. And then you would basically just need to add your container registry to your POM file, to pom.xml. That is the Oracle Container Registry definition that you've got from your region and your tenancy. And then once that is done, a Docker image will be built and added to the container registry, which you can then use to create a function from. So it's very easy to do, and it allows you to use the function serverless environment to its full extent. Now, should only take a little while until the last step for the compiling, and then we will be using curl to test it locally. So what also needs to be done, and which I have done before creating the instance because I have used a virtual cloud network that already existed, was that I went inside my virtual cloud network definition, which is this one, and then I went to my subnet that I have created, which is a public subnet. And in the default security list that we are using for the subnet, I have added the port 8080 for Micronaut. There we go. So that allows traffic from any IP address to the port 8080. There we go. So this is also very important to remember once you create the same. So going back here, yeah, we're at the last step. There we go. It has finished. So it took us almost 4 minutes. And now we are ready to run our application. So we will be CDing into Target, just to have a look. And here you see we've got our native application, Micronaut demo. And we can just run this using Micronaut demo, and we'll also add this so it runs in the background. And now we can test it. As you can see, it's running on port 8080 on HTTP. So let's try it out. I'll open a new terminal, and we'll do a time curl http // let's go and take our IP address on port 8080 / random. And there we go. And running it again, it's giving us a random quote each time. And by using time, we can also see some statistics about the call. Hope you've enjoyed this demo, and hope to see you next time for our future videos. Thank you.